Welcome back everyone to my channel Chemistry Made Simple for NEET. I am Dr.Lekshmy Subramaniam with a PhD in Chemistry. Today we are going to begin a new chapter, General Principles and Process of Isolation of Metals, Part 1. So this is a very important chapter which you have to go through thoroughly, and I have tried to include all the concepts, and you are likely to get many questions from this topic for NEET. And before beginning with the concepts, I would like to share something important with you. That is, when you practice for NEET Chemistry, you have to prepare inorganic chemistry from NCERT book itself. This is because it's fact based. This part does not consist of any concepts. And for physical chemistry, it's very important to study theoretical concepts as well as numerical problems from NCERT books. And organic chemistry is mostly based on concepts, and therefore one needs to clear his concepts by referring to the different books before solving questions. In organic chemistry, do detailed learning of reactions by a pen down method again and again. Run through questions every day. Learn all the formulas by heart. Make sure not to skip anything. With the regular revision, formulas should soon be at the top of one's head. Prepare redox reactions from Unit 8 of NCERT. One can remember most reactions based on redox. I have already uploaded the chapter here, and you can watch thoroughly the MCQs as well from this lesson and the concepts. And studying the types of reactions is very important. And most importantly, solve previous year question papers of AIPMT or NEET to get a fair idea about questions which are asked in chemistry. And after finishing a chapter, solve at least 50 objective questions to clear your concepts from that chapter. Make sure that you eat and sleep properly. All the tips I have given will have no meaning if you are not physically fit to attend the examination. And do not get nervous about the sections of chemistry where you are weak. By repeated revisions, one can build a strong base. But if you start to feel negative about your weak topics, then it may turn out to be demotivating your own self before the exam. Stay strong. Okay, with that we'll begin the first part of this lesson. And what we are going to do here in this lesson is that, very few elements like carbon, sulfur, gold, noble gases, they all occur in free state, because free state means they don't combine with other atoms. They exist as such, while other, see, for carbon instance, it just exists as C, sulfur just S, okay, gold and all that, while the others are seen in combined forms in Earth's crust. So the extraction and isolation, that is, you have to extract it. See, if it is seen in combined form in nature, you have to identify and extract or isolate these elements separately from its combined form, and it involves various principles of chemistry. And a particular element, it can be seen in a variety of compounds. That is, the process of metallurgy and isolation should be such that it is chemically possible. It should be easy and not very difficult, and it should be commercially viable. See, if you have to spend lots of money on that, it's not viable, practical. But some general principles are common to all the extraction process of metal. So we learn it thoroughly in this unit. For obtaining a particular metal, what you have to do is, first you have to look for minerals which naturally occur. What are minerals? Actually, they are naturally occurring chemical substances in the Earth's crust. You can get it by mining. Out of many minerals in which a metal may be found, very few are viable to be used as sources of that metal, and we call such minerals as ores. So just importantly remember what are ores, and how do you choose chemically viable, how can you extract a metal on based of the commercial side. All these things you have to remember well. Okay, now how do metals occur in nature? Elements vary in abundance. They are seen everywhere in the Earth's crust. So aluminium is the most abundant among metals. It is the third most abundant element in the Earth's crust, because 8.3% approximately by weight. It is aluminium. Okay, now major component of many igneous materials including mica, clays and all that, and also gemstones, these are all impure forms of aluminium oxide, Al2O3, and impurities range from chromium. See, in ruby it's chromium, and sapphire we have got cobalt. And iron is the second most abundant metal in the Earth's crust and forms a variety of compounds, and their various uses makes it very important. And iron is very important element, one of the essential elements in biological systems also. Okay, now you understood about all these things. Next, we will see some principle also of important metals. Mainly I have taken 4 metals: aluminum, iron, copper, zinc. Okay, ores of aluminum, bauxite and kaolinite. It's a form of clay. We have got the chemical composition here. Just remember this composition. For iron, mainly 4 ores are there: hematite, magnetite, siderite and iron pyrites. We have got the formulas here. Remember that well. Then copper pyrites, malachite, cuprite, copper glass. We have got the formulas, and remember the formulas well. Suppose they'll ask what is copper glass, and they'll give all these options. You have to know that it is Cu2S. Okay, now zinc blende or sparolite and calamine, zincite. So these formulas just remember. Okay, now how do you concentrate, or what is meant by concentration of ores? You see, when you get the minerals from the earth's crust, we have got many unwanted materials in it. So you have to remove that first from the ore. The process of removing unwanted material is known as concentration, dressing or benefaction. So several steps are there, and we have to select these steps carefully depending upon the differences in physical properties of the compound of the metal present and that of the gangue. And the type of the metal, the available facilities, the environment factor, all these should be taken into consideration. Okay, now firstly we have got magnetic separation. So what is this based on? Based on the differences in magnetic properties of ore components. So if either the ore or gangue or one of these two, it is capable of getting attracted by a magnetic field. So such separations are carried out using magnetic separation, like iron ores and all that. So the ground ore is carried on a conveyor belt which passes on a magnetic roller. You can see here the magnetic separation. You see, magnetic roller comes like this. You can see here magnetic particles will fall, and only here the grounded or non-magnetic particles will fall here, and it is this magnetic particles are attracted towards the magnetic roller, so that is why they fall nearby here. So we can collect it separately. Okay, next is Froth flotation method. What is Froth flotation method? It is used for removing gangue from sulfide ores. So remember, this method is used for the concentration of sulfide ores. So here what you do is, powdered ore is suspended and it is made with water. The powdered ore suspension, it is made with water, and then you add collectors and froth stabilizers. What are collectors? Pine oil, fatty acids, xanthates, etc. And what they do is they enhance or improve the non-wettability of the mineral particles, and froth stabilizers like Rasol's aniline stabilize the froth. So the froth means, it's like some bubble like thing, that is called that is what we call as froth. So the mineral particles will become wet by oils like pine oil collectors which we add, and the gangue particles by water. So when you rotate a paddle, it agitates the mixture and it will draw or pump air into it. Because of that, the froth formed will carry the mineral particles, and froth is very light. It is collected at the surface and it can be skimmed off. Then it is dried and then the ore particles are recovered. You can see the froth flotation process. I have represented this using a diagram. We have got a rotating paddle here. Then here we have got the this is the paddle that draws in air and it stirs the pulp, and here we add the pure pulp of the ore and oil through here. Here we get the mineral froth. So it's very easy. Okay, now next is important process is conversion to oxide, and before that after froth flotation we have got extraction of crude metal from concentrated ore. So the concentrated ore should be firstly converted into a form which is suitable for deduction. That is a very important step. Most of you tend to forget this step because straight away from the concentrated ore we cannot get the mineral. Firstly you have to reduce it. So usually the sulfide ore is converted to oxide. Only why we are converting it into oxide? Because we cannot directly reduce the sulfide ore. So importantly, oxide ore can be easily reduced. So you have to convert it into the oxide form first. So oxides are easier to reduce. And then the isolation of metals from concentrated ore have two major steps: conversion to oxide and reduction to metal. From oxide it is reduced to metal. Okay. So how do you convert to oxide? Two methods are there. First is calcination. That is, what is calcination? It involves heating and the volatile metal, because the vaporizable part of the matter will escape, leaving behind the metal oxide. See, I have given you examples: Fe2O3 plus X molecules of H2O. When you heat it, you get Fe2O3 plus X molecules of H2O. Like zinc carbonate, ZnO plus CO2. So like that. just heating of the particle, heating of the metal oxides. Okay, now then conversion to oxide you can also do by roasting. What happens in roasting? The ore is heated in regular supply of air in a furnace at a temperature which is below the melting point of the metal. So here what all reactions occur? Zinc ZnS plus O2 gives zinc oxide plus SO2. Similarly for lead and copper you can see the following equations. Then the sulfide ores of copper are heated in a reverberatory furnace. So if the ore contains iron, then it is mixed with silica because you have to remove iron from it. So what happens is that iron combines with silica and forms slag. It's also known as iron silicate, and then the copper is produced in the form of copper matte which contains Cu2S and Fe(S). So here just see the equation. Iron oxide plus slag will mix up and give you plus silica will mix and give you the molten slag FeSiO3. Remember all the equations properly. Then you can see the section of a modern reverberatory furnace. We are having the charge hooper here, and the hangers are here. Then tie rod with which you suspend this particles, and the charge hooper. Again we have got two charge hoopers here. Here we are having the air and oil here. Then magnesite, furnace charge over here. Then here we have got silica. So this is the cross section of a reverberatory furnace. Next, how do you reduce oxide to metal? First of all, it involves heating it with some other substance which acts as a reducing agent like carbon or CO, or even another metal can be used for that. So the reducing agent like carbon or whatever it is, that combines with oxygen of the metal oxide. Then metal oxide, some of it get reduced easily while others are very difficult to reduce. What is meant by reduction? Means electron gain or electronation. I have already taught you that in some units before. So anyway, heating is required. So to understand the variation of the temperature requirement for thermal reduction, we call it pyrometallurgy, and to predict which element will suit as the reducing agent for a given metal oxide, you have to use Gibbs energy interpretation. Okay, now because we don't know for different metal oxides it will be reducers and all will be different. Okay, now extraction of iron from its oxide. So oxide ores of iron, now after concentration by calcination or roasting, that is to remove water, to decompose carbonates and to oxide sulfates and all that, they are mixed with limestone and coke. Okay, limestone is calcium carbonate, coke is just carbon, then it is put into a blast furnace from its top. Here the oxide will be reduced to the metal, and with the help of thermodynamics we understand how coke reduces oxide and why we choose blast furnace. The main reduction step happening here is that FeO plus carbon will give you iron plus CO. So normally it can be seen that a couple of two simple reactions. One is reduction of FeO, other is C is oxidized to CO. So the two equations are given here. Okay. Next, what is blast furnace? Already we said that it's a furnace where reduction of iron oxide takes place in different temperature ranges. So what you do is that from the bottom of the furnace hot air is blown and the coke is burnt to give the temperature up to 2200 Kelvin in the lower portion. See, last year 2021 NEET there was a question from this part, that is the maximum temperature achieved by the blast furnace, because very confusing values were given. So many couldn't answer this question properly. So just remember all these points. The burning of coke therefore supplies most of the heat required in the process, and CO and heat moves to the upper part of the furnace. What happens in the upper part? Mostly in the upper part the temperature is lower. The iron oxides coming from the top, it will be reduced in steps to FeO, Fe2O3 and Fe3O4. So the reduction reaction takes place in the lower temperature range, and higher temperature range depends on the points of the intersection in this graph. That is we already saw this before. So you can refer to the textbook also about the curve of the graph or the intersection of the graphs. Okay, in the blast furnace we can summarize the reactions as follows, like from 500 to 800 lower temperature range. So these are the reactions taking place. Just note this down and learn. And at 900 to 500 higher temperature range, this C plus CO2, carbon dioxide is getting reduced with the help of carbon to CO, and here also FeO plus CO will give Fe plus CO2. Okay, now here in the blast furnace limestone is also decomposed to CaO, that removes silica impurity of the ore as slag. Always slag is in the molten state and it is separated from the iron. So the iron obtained from blast furnaces about 4% has 4% carbon and other impurities in smaller amount like sulfur, phosphorus, silicon, manganese and all that. We call this iron as pig iron, and it is cast into variety of shapes. Cast iron is different from pig iron. Remember, all these points are very important, and it is made by melting pig iron with scrap iron and coke using hot air blast. And it has slightly slower carbon content 3% and very hard and brittle. Okay, now you can see the blast furnace here. Okay, so the different temperature ranges are given here. You can see that, and the exhaust gases are given. So each part the reaction taking place is given here. Then the molten iron and all these molten slag, each temperature, what all reactions are taking place. Just go through this diagram well. Now with that we are coming to an end of the first part of this important topic, and once we finish off with this topic I will be also uploading the most important MCQs. Do share these videos with your friends as well, and don't forget to like, share and subscribe to my channel, and don't forget to press the bell icon, because as soon as I post new videos you will get the notifications immediately. I'll be coming up with another session as quickly as possible. Thanks for watching, and we'll be winding up for today.